Hi everyone, welcome to TLDR Week 4. This week, the learning outcomes are being able to troubleshoot and use dependencies, being able to troubleshoot and use gems and drivers, and also being able to find and modify config files, and more importantly, being able to find and know when to not modify config files. Dependencies. One of the things that we'll see frequently on our systems is rather than having code copied repeatedly, a lot of developers will actually use other people's code and refer to it, for example, a library. And that means we have programs that are dependent on other pieces of information. Dependencies help us save space and share code. If you are uninstalling packages that have dependencies, you should get warnings. I do not promise that you get warnings. Some packages want to be primary and can actually cause issues within the dependency. So if we're talking about a project, we can actually have projects where we will install something and it says, oh, I'm so sorry. Well, it doesn't actually say I'm so sorry. It just says I don't work. And it will say, I need X to be able to work. Maybe it's a language, maybe it's a library, maybe it's a configuration, and that's called a dependency. We can have version dependencies. For example, if you remember from Python, the difference between Python 2 and Python 3, you'll have some projects or programs that must use Python 2, some that must use Python 3. An example of a package dependency, OpenSSH actually has a dependency on libSSL. So if you want to use OpenSSH, you have to make sure that you have libSSL installed. It's also really popular for programs to assume you have the C libraries installed because a lot of things are actually written in C. Dependencies can end up leaving us open to some odd vulnerabilities. You want to think about the chain. Who owns the chain of what you're working on? Who's maintaining the code? And who's maintaining the repository? If you have a whole bunch of different people that are maintaining the different links in the chain, especially if you have A, which is dependent on B, B, which is dependent on C, C, which is dependent on D, etc., that can mean anything along that chain can actually break, and then you will need to deal with it. Package management. Sometimes when you're downloading unpacked source code, you actually have to do a compile before the install because it's not coming from a repository or repo like we talked about last week. Normally, you'll see something that is a file that has the word install in all capital letters. That install file is going to include instructions on how you install the package. If you're getting it from GitHub, they might have a README that would be the equivalent. Some languages will have required libraries that you will also need to install for that particular program to work. An example that I'm going to use is gems. Now, I actually picked this example because this ended up coming up for me at work a whole bunch. And because I don't generally program in Ruby, it was something that I wasn't really expecting, and I would like you guys to expect if it comes up. Ruby Gems is actually the package manager for Ruby. That is, the gem is supposed to be the self-contained format or library. There should be a public repository that holds all of these gems, and that should help us find dependencies. Each gems should have code, documentation, and specs. Now, in practice, this might not actually happen. I will tell you, I actually ran into this issue in the advanced security when we were doing some different installs and work there. There was actually quite a bit of gem dependency issues with one of the documentation programs. And so it's important that you start figuring out which pieces are dependent on what. If you have a dependency issue, you need to be able to figure out how to fix it, which means you're going to probably be doing a lot of installs. The activity that I'd like you to do is try installing and then playing with tmux. Now, if you've already completed the continue setup activity from last week, you might already have this installed, in which case, please spend some time playing with it and seeing the potential advantages and disadvantages of installing tmux. Feel free to pause me here and come back. Configuration or config files. Config files are used to set the initial settings or parameters. So a config file is how the program wants to be set up the first time so that you don't have to worry about setting it up. This is what the developers have decided they think should happen the first time. You might see this as a .cnf, a .conf, which is usually pronounced conf, or a .ini. Config editing. Because Linux allows you to do anything, it will allow you to edit config files. Sometimes you have to edit config files. Sometimes editing config files kind of opens a Pandora's box that leads to a black hole of doom and swearing. So typically config files are plain text. They are easily editable in any text editor like VI or Nano. Most config files will allow comments. Comments are actually how we enable or disable settings. So if I have, for example, SSH and I have a config file for SSH, I can go in and comment or uncomment different pieces depending on how I want it set up. This can actually be modified. A couple of pro tips here, things I've learned the hard way and I hope you never have to. If you're going to modify a config file, create a backup before you modify. That way, if it all goes completely foobar, you have something that you can go back to. Some config files are human readable, some aren't, some have GUIs, some don't. Because Linux is such a widely variable thing, you don't really know what you've got until you actually go in and look at it. There are some configs that are going to be checked at startup, some are checked more frequently. For example, common convention. If you have the name RC somewhere in there, it means it runs at startup. My example is the .bashrc. .bashrc runs at startup, and that will say how bash is going to work. Some configs actually get reloaded once you make changes. In the example of HTTPD, that service, you can actually reload it manually. The etc hosts file is actually checked pretty frequently. So different configs will actually have different rules, and you need to figure out which rule your config is following. The next thing that I'd like you to do is go look at your SSH config. What do you think is the most important thing in there? What do you think should be changed? What do you think shouldn't be changed? Take a moment to pull this up, go through it, pause me, and then come back after you've done this. Drivers. Drivers are a piece of software to make hardware work properly. For example, let's say I have a printer. If I have a printer, I need to be able to talk to the printer hardware. I would use a device driver to be able to talk to the printer hardware. Normally, this is what's considered a black box. I don't look in the driver, I don't play with the driver, I install the driver, and then my printer works like magic. These are generally built separate from the kernel. They are things that are installed later. A lot of drivers will come with your operating system. I use the example of printers because printers plus Linux can sometimes be absolutely fine and sometimes not work no matter what you do. Some printer drivers that come with Linux, it's actually called CUPS, Common Unix Printing System. This will allow you to choose the printer based off if the driver is available. So one of the unfortunate things that happens with Linux is a lot of printers actually aren't compatible. So for a lot of people that run Linux, they actually pick printers specifically based off of if the driver is compatible and part of the CUPS system. Sometimes we'll also have something called proprietary drivers. This means a person in the community did not write an open source driver. This was created by the company. Sometimes the drivers won't come with the systems. Graphic cards and Wi-Fi cards are actually a prime example of this. For example, if you are using a graphics hardware card like NVIDIA or AMD, they are probably going to have a proprietary driver. There's no guarantee that it works for your system, and it means 3D gaming on Linux can sometimes be a problem. Wi-Fi drivers are the same, which is why a lot of Linux systems get the reputation of flaky Wi-Fi. Some systems like Linux Mint are meant to be very much easy, press and go. So they're going to have more driver managers or a driver manager at all compared to other systems. An example of a system that might have less is Fedora. Fedora is against proprietary drivers, and it will actually go out of its way to make proprietary drivers difficult to use. If the driver doesn't work easily or can't be found, unfortunately, there is no good solution for this. The solution is that you write your own driver. A lot of people don't like doing this, which is why they try to be careful about the hardware that they're buying and bringing into the system. This is also why Linux is more popular on servers than personal computers, because servers aren't generally changing out their hardware like this in the same way. I do not have a particular lab for this week. I assume that you are continuing to work on the Continue Setup lab, the User Management labs, and the grep sed and awk labs. And you will get a new activity for networking next week for the lab. If you have any questions, please let me know.